Welcome to the NYNJPA weather video discussion for education. And today we're going to talk about moisture advection and precipitation. So currently we have a forecast out here. This is for, April 6th, where we have a heavy rainfall event on the way. And this is from the HPC, where they're expecting over an inch of rain over the Philadelphia and New York City metropolitan areas. So what we're going to do today is look beyond the solution here. This is the model output, and try to determine whether this model output that is provided by the HPC is actually supported by the actual observations. I'm going to show you what to look at in terms of the observations. Well, first of all, we can always go to the basics, the radar. Currently, we have very heavy rainfall, very impressive rainfall over portions of the mid-Mississippi River Valley, over Mississippi, Arkansas, lifting up towards the Tennessee River Valley. So clearly we have a very heavy rainfall event on the way. But the question is whether this heavy rainfall translates northeastward towards the northern Mid-Atlantic. Well, let's take a look at the satellite picture. This is the infrared satellite picture. You can see our storm developing and very strong lifting associated with this storm. You know that because the cloud tops are very high in the atmosphere. Remember, the colder the cloud top, the higher it is in the atmosphere. The higher a cloud top is in the atmosphere from the surface, the stronger the lifting. So we have the attributes here clearly of strong lifting associated with this potentially heavy rainfall. But of course, you don't just need strong lifting, you also need moisture. So the next factor you look at is the water vapor satellite picture. Now, this is really helpful because you can see different aspects of where moisture is coming from the mid and upper levels. Not the lower levels, because it doesn't really pick that up very well. So you have a very strong fetch from the tropical Pacific. You see that with our subtropical jet stream. You also clearly have influence from the Gulf of Mexico. And you can also see very deep moisture in the mid and upper levels of the atmosphere. So clearly we have support for very strong moisture transport at the mid and upper levels of the atmosphere. Now we see this even further in the moisture transport that we can get from the SPC, spc.noaa.gov. This right here is 850 millibar moisture transport. So this is for the middle portion of the atmosphere. Now clearly, with the skies clear over the northern Mid-Atlantic, you don't have much in the way of moisture transport. But you see this right here? This is green and then red. When you're in the red and the green area, especially the dark green, that's very strong moisture transport. And what that's doing, combined with the lines here, this right here are your vectors. The longer the vector, the stronger the wind. So what it's telling us right now in this case is that we have a strong low pressure system developing over Texas and very strong moisture transport from the Gulf of Mexico into the Mississippi River Valley. As this low pressure system translates to the north, we would expect this moisture transport to go along with it. Now, it likely would not be as strong because this moisture transport is enhanced because it's right over the Gulf of Mexico. But you get an idea of the type of moisture transport capable with this storm to support this forecast. Now, another aspect that you want to take a look at is precipitable water. What this basically is the value of the water of the moisture in the atmosphere for the lowest 400 millibars of the atmosphere. So this is basically from 600 millibars on down to the surface. Now, typically, what you want to look for a heavy rainfall event is about 1 inch, which is this light green here, of precipitable water. When you start getting into the dark green, around 1.5 to 2 inches, and then above 2 inches, well, that's tropical-like. And that's where you start to get the support for very heavy downpours. Now, at the same time, when you have this type of precipitable water in the atmosphere, and you get severe thunderstorms, that tends to weaken an overall precipitation shield as the focus becomes more concentrated with those thunderstorms. But what we have here is clear support for tropical type air mass lifting northward into what's clearly a very dry air mass at the lower levels of the atmosphere. So again, this supports an environment where you're going to have strong lifting and plenty of moisture. Finally, what you want to look at is precipitation potential placement. Now, what this is, it kind of tells us the nature of the system. Where you have the best cross section of lifting, instability, and moisture. And when you start getting above 1 inch here, between 1 and 1.4, that's when you get the best support for heavy precipitation. Now, it's dependent on your temperatures. Below 30 degrees, let's say in the winter, anything in the 0.5 to 1 inch range supports heavy precipitation. When you're around, let's say 35 to 65 degrees, you want to be between 1 and 1.4 if you're looking for a heavy precipitation event. And then when you get into those warm summer nights above 75 degrees, I want to be above 1.5 to support a heavy precipitation event, and certainly above 1.8 when it's over 80 degrees. So you can see here that this aspect here is strongly dependent on temperatures, which is related to instability. So when we tie all this back together again, what do we have set up? Well, we have a storm that is capable of strong lifting, strong moisture transport, and also available moisture at the mid, upper, and lower levels of the atmosphere. As you move forward in time, what you want to do is take a look at this aspect right here, the precipitable water, and see how that increases over the northern mid-Atlantic about 12 hours before the event, because that will give you the true measure of how much moisture is being pulled off the Atlantic Ocean. Well, I hope you learned something about heavy precipitation forecasting and how to use the latest observations from the SPC and from the National Weather Service to forecast a heavy rain event. Have a good night, and as always, I'm your meteorologist, Stephen DiMartino. I hope you stay safe out there.